Offering podcast. We are today talking to Jon Sasmor, who is a mineral guide and a mineral clinician working with clients, has deep background in mineral science and has studied with some of the major schools that teach about mineral balancing. His website is minbalance.com to get more information on that. And I hope you enjoy this interview with Jon. All right. Well, Jon, thank you so much for joining the Peace Offering podcast. I'm very excited to talk to you about minerals. It's been I think for me, it was somewhere around June of this year, June of 2023, that I became particularly interested in it because I had come across some information that had indicated that people that had high iron, it could negatively affect males that had high iron. It could negatively affect their testosterone in a few different ways, and that just because I have a curious mind, that got me going into, well, what else can happen here from downstream of the mineral landscape, because it seemed pretty clear early on, and correct me if I'm wrong, but that minerals were really kind of a terrain mechanic that was regulating many larger molecules, proteins, hormones, and it had really systemic impacts in that, maybe even as far as the types of bacteria that might be growing in the colon and regulating the microbiome in various locations. So, do you see it this way? Do you see minerals as sort of a fundamental terrain mechanic?
I think that's a great way to look at it. They were called the spark plugs of life by Henry Schroeder, who was researching so many different minerals. And one of the focuses has been on minerals as enzyme cofactors, where the mineral is the key to turn the enzyme on. But they also do a lot of other things because they balance each other. So if you take more of one mineral, that indirectly might give you more or less of another mineral. And that might be a really important role. And then they drive transport pumps where one mineral goes in one direction across the membrane and it brings another one the other way. And then you have the gut microbiome and the other microbiomes around the body. So when you're eating your minerals, they're for you, but they're also for all the trillions of organisms inside you. And it's like a game to see who can get the minerals and control them. Can we take those minerals up with our transporters? And can we use them for what we want? Or maybe someone else is there who wants the minerals and is going to steal them from us. So actually, the microbes love extra iron. They also love the other minerals. And we have whole systems set up to control the minerals and keep them. And that's even called nutritional immunity. And it's an important aspect of our immune system, which is we want to keep control of the nutrients. We want to share them with our friends, but not our enemies. We want our own cells to have plenty of them in the forms that are bioavailable that we can use. So yeah, the minerals are at the core of our body, and they can't be replaced. We need them.
Wow, that's I've never heard it put quite that way, but it really does frame it clearly. There's a nutritional immunity, and that there is this sort of competition, bargaining, fight in some cases over different minerals that we want to manage for our friends and ourselves, and not the other ones, not the bad guys. How did you get into this? Like, what led you into, because looking at your CV, you've trained with a few different mineral balance schools. So tell us about your background.
Yes. So I started doing a mineral balancing program myself to try to get healthier, feel better, more energy. And that was by the method of Dr. Larry Wilson. And that helped me tremendously. And so that was my start. And then a few years down the road, I started exploring some of the other methods. I took the training with Dr. Rick Malter, who's one of the greats in the mineral balancing field. He's looked at so many hair tests through the decades. And the hair test is what saves him from a probable heart attack, he says, because he found out about his low magnesium that way. So I really got into the details of how to do the interpretation with Dr. Malter. And then from there, I kept hearing about this dynamic of copper and iron, which you mentioned earlier. And from that direction, I trained with Morley, Robbins, and Kristan Kershaw in the Root Cause Protocol Institute. And that's a newer aspect of the mineral balancing, a new method that really adds a lot more insight into why copper isn't working for many people. So the key is that copper and iron, they're really important to each other. And we have to be looking at both of them together and at the dynamic, the dysregulation among them. So those are the directions I've come from. And also I've read a lot of other things. I've read a lot of journal articles and books and looked at the various giants of mineral balancing.
And when you do work with clients, you're running HTMA, which is, for those that don't know, hair tissue mineral analysis, what you were talking about before, and doing a combination with blood work. And you were telling me offline, how many HTMA tests have you done with clients?
I looked at several hundred of them by now.
Which is amazing. It's what a great data set to personally get your hands on, let alone the trainers that you train from. And so, can you give us like, the hallmarks of the Dr. Wilson approach versus the Dr. Malter approach versus the RCP approach? Because what it seems to me, and I have far less experience than you, but when I look at these different approaches, I recently interviewed Dr. Rich Orley, who you told me you listened to a lecture by, and and it seems like practitioners have a preference for certain minerals being beneficial or being negative, or there's a focus on their sort of therapeutic work or clinical work around those. And I wonder if you could juxtapose these three different systems in those kinds of terms for us.
Yes. Let's look at the historical background of it a little bit and how the differences developed. So just in the background, sometime around 1941, iron started to be added to the food supply. So you didn't really have these mineral balancing programs before that, but then around 10 years later, George Watson started to notice a lot of people had various kinds of mental illness, and there were a lot of people who had malaise or fatigue that their doctors couldn't describe. Their doctors said they're fine, but they just didn't feel right. So Watson looked at the research of Ancel Keys. Now, Ancel Keys is infamous for his theory about cholesterol and dietary cholesterol causing heart disease, except that that's been debunked enough that the cholesterol got taken off the nutrition label in 2015 because the dietary cholesterol doesn't affect the blood cholesterol in most people. But in any event, Ancel Keys did some other research where he was trying to find out, I believe during World War II, how it was safe to refeed starving people. So people who had been starved because of the war needed to be put back on food. But the problem is, if you feed people rapidly after starvation, they get what's called refeeding syndrome, where the body tries to do things too fast at once, and some other nutrients get depleted faster than they can go in, usually potassium. People die of hypokalemia. They haven't eaten for a long time, eat a giant meal or a few giant meals, and then 3 days later, they might be dying. So the research was, how is it safe to refeed people who are starving so that they become healthy again? And the important part that Watson noticed from this is that the people who were starving, they were volunteers who did this study, and they were starved for a number of weeks, and they developed symptoms that were indistinguishable from mental illness. And then when they were properly refed, and I don't know the details of it, the mental illness would mostly or entirely go away. So they could get very depressed or anxious or maybe even schizophrenia or hallucinations, various neurological symptoms.
Is this
But
the
it was,
Minnesota starvation study? Is this?
yes,
Okay,
correct,
I've heard about
exactly.
this, but in a different context. Okay, so please go ahead.
Yeah, so Watson noticed that starvation of nutrients can produce the same symptoms as mental illness. And then he was doing research based on smell, and he found that there were different biotypes of people. And to different biotypes of people, different substances would smell different. Like thiamine is the one that he started with, vitamin B1. And depending on the biotype, thiamine would smell way different to people. To some people, it was great, and some people, it was terrible. And from this, he went on with other nutrients, and he realized that the different biotypes were different categories of metabolism, and that they each needed different sets of nutrients to balance themselves. And he called the groups slow oxidizers and fast oxidizers. And then he had a third group called sub-oxidizers that were kind of just off the track of metabolism generally. And later he added a group called variable oxidizers that would switch back and forth quickly. But those were very rare. Most people then were fast oxidizers, whereas most people now are slow oxidizers. So the concepts of fast and slow oxidizers that we use actually started with those Minnesota starvation studies of Ansel Keys in the war. And so George Watson identified the patterns, and he realized that some people who might have something that looked like schizophrenia needed one set of nutrients, and then another set needed an opposite or at least very different set. And that both of them could improve with nutrition, but you had to look at what was the biotype. And besides that, the nutrition, at least in some cases, could completely resolve the symptoms. And I think he said he had 80% improvement in all sorts of mental conditions. And then he went on with the research about people who just didn't have energy. And he also had great results with that with his nutrition program. So that was the historical root of slow oxidizers and fast oxidizers.
That's amazing. I had no idea. Before you continue, do you think that these three categories are essentially categorizations based on thyroid health and thyroid efficiency? I mean, it kind of sounds like what you are describing when we're talking about speed of metabolism.
That's what Dr. Eck thought, who came along next. So Watson believed that it was about the differential rate of burning of carbohydrates and fats. So he didn't, as far as I know, he didn't connect it with the thyroid and the adrenals the way that it was later. And Watson wrote some great stuff about the connection between mind and body. And so this was 1956. He published his paper, Is Mental Illness Mental? Suggesting that starvation of nutrients can produce symptoms that might be called mental illness, but that he could fix them with nutrition. And Watson has 2 books. They're wonderful. He's such a great storyteller. He tells about many of the people that he worked with. So they might be a little hard to find now, but well worth reading. And going on with the thyroid and adrenals, Dr. Paul Eck was the one who was studying hair analysis. And he made the connection between patterns on the hair tissue mineral analysis and Watson's concepts of fast and slow oxidizers. Eck found that he could classify people based on the hair analysis into these groups and then give them separate sets of nutrients. And Eck also contributed the thyroid ratio and adrenal ratio. So he figured out the different ratios of the electrolyte minerals and what they said about how well the glands were working. So that according to his version of the theory, fast oxidizers usually would have both a fast thyroid and fast adrenal activity, and vice versa with slow oxidizers. And according to his theory, there's an important pattern called 4 lows, when the 4 nutrients that are first on his chart, calcium, magnesium, sodium, and potassium, all are low. And that may be analogous to Watson's sub-oxidizer, where it's a burnout state where it's kind of off track and spinning the wheels in the ditch, and you have to really slow down and get back on track to bring those mineral levels up. Dr. Watts worked with Dr. Eck in Phoenix, and I believe both of them trained Dr. Malter. And Dr. Wilson also worked with Dr. Eck for many years in Phoenix. And then Dr. Watts went on to found his own lab, Trace Elements, in Texas. And Dr. Watts calculates the fast and slow oxidation by a slightly different method using the calcium phosphorus ratio, which comes from the work of a dentist, Dr. Melvin Page, who found that the balance of those 2 minerals in the blood also determines biotypes of the activation of the sympathetic and parasympathetic nervous system. So that also shows up on the hair test. And so the hair mineral test ends up being a very good, simple, non-invasive test where we can classify what's your pattern of minerals, what's your pattern of energy, what's your pattern of stress, how well are you responding to stress, are your glands going too fast or too slow, how can we bring you closer to balance? So that's the history of the hair minerals. And there's another important step after that, which is what Morley Robbins has done, where he looked at the copper and he realized how important and how closely tied the iron is. And he also realized that the hair mineral test isn't really enough to look at the specific dynamics of copper and iron in the body, so that we also need a group of blood tests. There's an ideally we'd be able to test the peroxidase activity of ceruloplasmin, which is how well the ceruloplasmin enzyme is oxidizing iron, but that test is only available in research labs. So what Morley Robbins did instead is he developed a group of blood tests that taken together give us a lot of information about your status of copper and iron, and also several other related nutrients. So that builds on the hair tissue mineral test, which we definitely still do to look at the stress and energy patterns and how to improve with those in a personalized way. But for the iron and the copper regulation, those blood tests that Morley Robbins has added are very helpful.
Wow, John, thank you. That is really illuminating for me. Probably not so relevant to most people, but it's so helpful to get that historical background. I always wondered why it seemed like there was a preference for HTMA in the psychiatry world, and it seems like it's just simply uh, teachers teaching teachers, with that initial Minnesota starvation study, that when you see mental illness show up, you need a psychiatrist, psychologist to intervene. And if somebody gets really good at it, then other psychiatrists are going to want to study from them. And then you just kind of like, there is sort of a preference to remain in that domain. Um, Not a whole lot of crossover into more physiological or chronic disease scenarios, but until relatively recently, anyway, it seems to be like if you go to a conventional physician with an HTMA, they just kind of look at you sideways. They're like, okay, totally useless. Don't know what to do with this. Let's run some blood work, and so that's really helpful. Uh, and so when you are using HTMA, you personally, to help clients, do you, it sounds like this is really kind of a phenotyping tool, number one. And then once you identify someone's phenotype or biotype, that you can then, there is sort of a pattern of mineral deficiencies and excesses that go along with that. It gives you an indication downstream hormonally what may be happening. And when you get that sort of pattern, it's depending on how stressful how stressful a person's life is, that gives you an indication of dosage for repleting or supporting their phenotype. Is that a good way to state it?
Yes, I think that's right. In terms of the hormones, I think it's important to mention this enzyme called the PAM enzyme, which runs on copper and zinc and vitamin C, but the main step is copper. In some contexts, there's a second step that also needs zinc. And the thing is that this PAM enzyme, it activates all sorts of hormones. The whole endocrine system, upstream of that, there's copper. So if you don't have the PAM enzyme working, you can't activate your sex hormones, your blood sugar hormones, all sorts of other signals that are supposed to be going through your body. They're just not going to be working right because they're not activated at the step they need to work as hormones. So yeah, that's another reason that copper is really important.
Great. Um, do you see in your work that there are broad nutritional mineral deficiencies among the general population, or does it, because I hear things like 80% of people are deficient in magnesium, 60% of people are deficient in iodine, 66%, 2 out of 3 people are deficient in selenium. So often you'll hear these sort of broad nutritional deficiencies being mentioned by healthcare practitioners or health coach gurus. And I wonder how much of that is just repetition, imitation, repetition, and how much of that is actually based on personal clinical experience testing people? What's your sense of it?
That's a good question. Well, how would we know? Uh, so when I look at the results, I'm more often looking at ratios and patterns and how certain sets of minerals compare with others. So I actually spend very little time thinking about the question, is the person generally deficient in this, or rather than do they need more of this one relative to that one? And let me read something about this because I think it's an important topic. This is by Dr. David Watts, who's the founder of the Trace Elements Lab. And this paper is on the Trace Elements website. I believe it's called Nutrient Interrelationships, Minerals, Vitamins, Endocrines. This paper was sent to me along with my first mineral balancing program by one of my mentors, Sheila Dobson. And it had a star next to this passage, which to this day I still think is one of the most important things that I've read. It says, nutrient interrelationships are complex, especially among the trace elements. A mineral cannot be affected without affecting at least two other minerals, each of which will then affect two others, etc. Mineral relationships can be compared to a series of intermeshing gears, which are all connected, some directly and some indirectly. Any movement of one gear, mineral, will result in the movement of all the other gears, minerals. The extent or effect upon each gear, mineral, will depend upon the gear size, mineral quantity, and the number of cogs in the gear, number of enzymes or biochemical reactions the mineral is involved in. This meshwork of gears goes beyond just the mineral relationships, extending to and affecting the vitamins, hormones, and neurological functions. So when we think about these intermeshing gears, then maybe we can learn something about, are people deficient in this mineral or that mineral? But really, with the state of the soils and how the minerals are being blocked going up the food chain, and that's something else we could talk about, we're probably largely deficient in a lot of them. But in many cases, what causes the concerns that people have isn't just that they're deficient in one mineral or another, but that the minerals are out of balance, especially in certain ways that the modern world tends to promote, like adding too much iron and adding all sorts of other things that tend to deplete copper. So maybe it's not so much that we're deficient as that copper and iron are out of balance, and there are several other pairs that are out of balance, and more than just pairs, there are whole webs that are out of balance. So I would say it's probably true what people are saying, that these individual minerals are deficient, but it's even more important that the minerals are out of balance with each other.
Yeah, that's a great point that you're making. And so if you were to then approach the issue of mineral balancing from the standpoint of what are the additives to the food supply that have been could be causing this imbalance. One of the obvious ones is iron, as you mentioned, 1941 it was started to become mandatory to be added to grains. And then I think that number was doubled again, the amount in 69. And so are you aware of other minerals that have been added or that are accumulating potentially in the soil that may be throwing off this balance?
Synthetic B vitamins are another one that comes to mind. And of course, the vitamins and the minerals are interrelated with each other. So the synthetic B vitamins tend to imbalance each other, but also to deplete certain minerals, especially potassium. Potassium in turn is needed for the copper transporter, so copper loses too. Vitamin A and D in synthetic forms get added to some things like dairy. And also, aside from additives to processed foods, we have supplements that have become very popular, including multivitamins that often include a lot of ingredients that shouldn't be there. And some of those ingredients tend to deplete others. So for example, some multivitamins contain copper and zinc, but there's so much zinc relative to copper that the net effect is anti-copper. And they might also have some molybdenum, which is going to go and round up copper wherever it can find it and use your copper that way. Vitamin D is another one that can deplete potassium.
Fascinating.
Basically, every synthetic nutrient has effects on others. The more that
so
we
you're
can
saying
do with,
and you're saying that's not the case if that is that also the case if it's an organic vitamin that is coming from in supplemental form, or are you just saying getting your minerals and vitamins from food, where there is probably dynamics occurring within the food that makes the body able to choose what it wants and what it doesn't want?
mostly we want to get our nutrients from food, from whole foods. And when we take supplements, it's better if they're whole food supplements. Mostly. So there is the modern world, and things are out of balance in certain directions, and maybe they're further out of balance than when we started. And so if you look at the evolution of the different protocols that I was mentioning, George Watson was giving people really a lot of synthetic nutrients, all sorts of stuff. Some of the groups got huge amounts of iron in their multiple vitamin, multiple mineral formulas. He was trying all sorts of stuff. And then you go toward the 60s, 70s, Dr. Eck, Dr. Watts, Dr. Wilson, their programs are using pretty aggressive formulas of synthetic supplements, often with a lot of zinc and not very much copper. Even the people who did get copper in those programs, they were still taking many times, probably 8 times as much zinc. And that's likely to be enough to block copper absorption to a significant degree. So then if you go further along, another important thing that Morley Robbins has done with the root cause protocol is he's actually gone back to whole foods a lot more. There's a strong emphasis in that community on eating whole foods, on the ancestral organic whole foods diet. And most of the nutrients are coming from sources like the grass-fed beef liver, which is a great source of almost everything in natural balance with each other, especially if the cows have to be eating their natural food, the grass. And then there are other food components of the protocol. There are some components that we're getting from synthetic or from isolated supplements, and those are still ones that are considered important in today's world, or for people individually based on their results. So sometimes we might recommend something that's personalized based on the hair or blood testing results, specific nutrients. So I think those are safer if you do them in the context of looking at your results and knowing that this is something that you need for your pattern to restore balance, instead of taking it in a multivitamin, even a whole food multivitamin, which still might have some of the wrong nutrients for you that push you in the wrong direction.
Yeah.
But whenever possible,
It's better to think of beef liver as your multivitamin.
yeah, beef
So
liver is a great multivitamin. It's been around for a long time. It's been tested by many generations. Egg yolks are another.
yeah. Yeah, and so I think that's for people that aren't interested in the details of these ratios and the different minerals, like that's I think the grand takeaway is, eat your beef liver, uh, and even though that maybe not palatable to you, there's different ways to take it, get it into your diet that can be more palatable, like taking grass-fed beef liver caps, so that you don't have to taste it, but you could go hard and just take it raw. Some people do that. I have tried that. It's not a culinary experience in my personal view, but it's the best way to get it. And the same thing with egg yolks. I'm there with you. Those I can tolerate taking raw, and that is also the best way to get it. So that's good to hear. And so when you're saying, ancestral diet, we're talking about something like Weston A. Price, Nourishing Traditions, as maybe a starting point for people.
Yeah, Sally Fallon has written the Nourishing Traditions Cookbook, and she has another book that I think is really great called Nourishing Diets, which is a sort of a world tour of traditional cultures
Okay.
and what they were eating. So if the cookbook is too intimidating, that the recipes are too complicated, read the Nourishing Diets book and just look at what the ingredients were and get the ideas. People were really doing amazing stuff for thousands of years with their food. And let me say a few ideas about the liver and the egg yolks, because maybe that might be helpful to some listeners about how to eat them and enjoy them. So I'm lucky. I think that the liver tastes really good. I like it a lot. But uh, there are different ways you can do it. So some people might cook it and add different flavors, but something I do that I think makes it taste better and is very simple is that I cut up the liver into small strips and I dip it in boiling water only for about 10 or 15 seconds. It should be frozen for at least 2 weeks before, like Sally Fallon says, just in case there were parasites in it. And so then you unfreeze it, cut it up, dip it in the water. And so it will be cooked on the outside, a little bit cooked, but still quite rare or almost raw inside. So that's one way to do it. And another way is with the capsules. And ideally with capsules, generally, it's better to empty them into something and eat them as food, because the experience of chewing in your mouth notices what's there, you taste it, your body gets ready for it, and also you absorb nutrients in your mouth. There's an article that says that vitamin B12 and A and D are ones that might be absorbed in the mouth. There's a lot more research that could be done about that. But to have an experience most like food, it's better to chew it. One thing that I like to do to make some things taste good that otherwise people don't like is I make a recipe which is called activator goo. And it's based on Weston A. Price's mixture of oils, which was cod liver oil and high vitamin butter oil. So I use the emu oil, the walkabout emu oil, instead of the butter oil, because the emu oil is the highest known source of vitamin K2 MK4 version in the modern food supply. So that was what was in Weston A. Price's butter oil. So you can mix these two oils, the cod liver oil, I use the Rosita, and the walkabout emu oil. And then you can empty a liver capsule or a few liver capsules into that, or a kidney capsule, really anything with a savory taste. And you can put a little bit of kelp in there, which has a nice seaweed flavor, and you can add mushrooms. Like there's one that I use called the Ergo Plus by Real Mushrooms. We could talk more about ergothioneine, which is an interesting nutrient that comes from the soil microorganisms. Anyway, by the time you mix up all these flavors and you have your mushroom flavor mixed in and a little bit of seaweed flavor, you don't taste the cod liver oil and you don't taste the liver so much. It just tastes, I think, very good. So
Wow. Where is
one,
this? Where can one find this recipe?
you can find it on the MinBalance website, minbalance.com. And if you click on recipes, there's a recipe for activator goo.
Very cool. Well, I will try that. That makes a lot of sense. That makes a lot of sense. Okay, so let's circle back to talking about iron and copper. And is it true that if you are copper deficient, dietarily copper deficient, because you are not eating oysters or beef liver or some type of whole food vitamin C, that you will accumulate iron dietarily?
First of all, let me say that oysters may not be a good source of copper because oysters have such a high ratio of zinc to copper that the zinc can block the copper, even though there's a lot of copper in them. And that may be a lesson for all the supplements out there with copper and zinc in them that are a ratio of 10 to 1, 15 to 1, 20 to 1. Well, you can eat oysters with huge amounts of copper, but even huger amounts of zinc, and you end up with case studies of copper deficiency.
Oh, interesting. Okay.
So going on from there to the part about iron, generally iron needs copper to move around. Iron is very important to carry oxygen through our bodies, but it can't do its work without copper. So the way that it works out, where the iron gets trapped, how it gets trapped, whether the numbers show high or low in the blood, there are different phenotypes of the copper iron dysregulation. But basically, it's correct that without copper working in ceruloplasmin enzyme, the iron is stuck and it can't get absorbed right and it can't build up right. I mean,
So
it
being
can't,
stuck in tissue, say for example, like liver.
yeah, sorry, it can't get absorbed right and it can't get mobilized right within the body. So it gets stuck in the liver, it gets stuck in the spleen. Most of the recycling of iron in the body is done in the spleen. We have a whole intricate system to recycle iron in the spleen after it's broken down from old red blood cells. But to get out of the spleen and used again, it needs the copper, it needs the ceruloplasmin.
Okay, so the issue is between, say, having a copper deficiency is not so much that you will overall accumulate iron. It's that the iron that you are getting is not being mobilized and it's stuck in these tissues. Is that a better way to say it?
Yes, the iron is stuck. Copper is missing in action, iron is stuck. That's, I think, how Morley Robbins would say it.
Yeah, I think I've heard him say exactly that. Um, okay, and so there are cases, I think in my most recent interview with Morley, he was saying that when you get an iron panel, and I'm assuming that you also run an iron panel as part of your clinical work.
Yes.
Um, you've got for if you want to hear way more detail about iron metabolism, go check out the second interview I did with Morley. For those of you listening now, because we get super nerdy in there about these blood panels, but you've got markers like TIBC, total iron binding capacity, serum iron. Also, you're looking at hemoglobin. Of course, that is a major store of iron in the body. Ferritin, and I personally also order transferrin because I want to know specifically transferrin saturation, not only the iron saturation, but how much is saturated by transferrin, and I'll get to that in a little bit. And he was saying that at looking at these and the 1,000 plus that he's looked at, that 95% of people fall below his ideal numbers of where these iron metrics should be at. And that, that 5% difference is above. So you could call them like high iron people, right? Is that your case also, that you see it predominantly people are showing lower iron blood markers?
I would say there's a mix. Which blood markers was he talking about when he said that? Do you mean?
I don't want to misquote him. Just in my memory, it was sort of like uh, it was it was generally low blood iron and generally high blood iron is kind
Oh,
of how
okay.
it was in my memory.
Okay, so that makes sense. He's probably talking about the serum iron, which is a measure not of how much iron we're eating, but of how much iron we're recycling, because 95% of the iron is recycled. So I think what he was saying is that 95% of people have a low serum iron, indicating low recycling of iron, indicating exactly what he's saying, that the iron is stuck. And I don't know that it's quite 95% because there are some people who are high, but that sounds about right, that more often than not, people are low in the serum iron, but that's because the iron is stuck. It's not because they need to eat more of it. It's because the 95% of the iron that's coming from recycling, it's not recycling, it's stuck.
Yeah.
So that's where we want to work on it. We want to get the recycling working.
And how would you approach it if you saw the opposite? If you saw high serum iron and high iron saturation and high transferrin saturation?
Well, in those cases, there's probably a more active situation of iron overload that's actually circulating around the body. So that's probably going to be causing various kinds of symptoms. Now, you mentioned hormonal symptoms, but the iron can cause oxidative stress really anywhere, in any organ, any system, in the brain, in the heart, in the mind, in the body. So there's probably more of an acute stress situation there. And it might be, depending on what the options are and if people qualify, it might be that blood donation would be very helpful in that situation. I mean, that's beneficial for a lot of people, even who are showing low iron, because it helps get the iron cycling started. But if there's actually an excess being mobilized already, maybe that's a situation where it's a little more urgent to think about that aspect.
Yeah, that's really interesting. That you could sort of kickstart the recycling system by donating, which is that's counterintuitive, I think, especially for people that have been trying to increase their iron in their blood markers anyways.
Yeah, there's an article about the peculiarities of iron. And one of them is that we are designed with a backup system for iron, which is that we store it in case of blood loss, because if we lose a lot of blood, we can't eat the iron fast enough to rebuild the blood. So the body wants to have some extra on hand. Whether we need that as much in the modern world when we're not exposed to blood loss so much on our own, that's something that's raised by this article. I believe it's by Dr. McCord.
And when it comes to, you have mentioned this sort of imbalance. That's a fascinating article you told me about. Excuse me.
Bless you.
About copper deficiency among people that eat a lot of oysters. That is really wow. So in what ratio do you like to see zinc in copper?
Beef liver.
Which is what? Is that a 1-to-1? Is that
Well, honestly, it's going to vary a lot based on what's in the soil. So we don't really know what's in any food that we're actually eating because the foods vary a lot. But in the long run, if you eat most of your minerals from food, then you're going to get them in about the right proportions. Now for copper, we are starting to supplement copper more and more. And a lot of people are really finding a lot more energy from that. That goes in a context where people are starting off really depleted in copper. So there's this other paper I really like by Raoul Wapner, Wapnir, and he calls copper a victim nutrient. So usually we don't like to use victim thinking and think of ourselves or others as victims because we're not going to be happy if we keep thinking about victimhood. But it's kind of fun. It's a mineral. We'll think of it as a victim. But it really is a fitting thing because you take too much vitamin C, knocks the copper out of ceruloplasmin, especially in a synthetic form. You take iron in your food or wherever else you get extra iron, knocks out the copper. Too much zinc, copper is gone. Too much vitamin D. All these different sources, as well as the other nutrients that need copper along with it. Copper can't keep up. And it ends up that copper is a weak point in the modern world where all these other things that have happened in the world, they come together and they all deplete copper. So many people are finding that they're low in copper. And sometimes it gets called copper toxicity because it got figured out in the 1970s that copper wasn't working right. But it wasn't really looked at then in the context with iron, where what happens, like you said, Jonathan, when copper isn't working right, the iron gets stuck. So they weren't looking at the iron side of the picture. And so it was thought, well, copper's not right. Things aren't right, copper's not right, it's copper toxicity. Well, it's kind of, and this it goes to the difference between the different programs. It's not really that copper is toxic, but you can make copper toxic by throwing all these things that mess up copper enzymes, the iron, the zinc, the vitamin C, all of these synthetic supplements and food additives. So you can knock copper right out of ceruloplasmin, and then you're losing your copper function, and you have this copper that's not where it's supposed to be, but you also have the iron. And that's the part that was missing before, is the iron side of the picture. So that's what root cause protocol method would focus on. Rather than the ratio with zinc, they would look at how are copper and iron interacting. Let me say one other thing about the zinc. There are 6 minerals at least, that bind to ceruloplasmin. So calcium and sodium are part of the structure of ceruloplasmin. So that's very important when it's built. And copper is the key. There's 6 to 8 coppers in the ceruloplasmin, and they make the enzyme work. They make the ceruloplasmin do this thing it does with the iron, where it changes the iron from +2 to +3, so the iron can move around. So copper is the key to ceruloplasmin, and then iron binds with ceruloplasmin as the substrate, where it gets taken out of the cell and oxidized, and then it can move around in transferrin. Cobalt will bind ceruloplasmin, but it will replace the copper. And so it might inactivate the enzyme. I don't know very much about this aspect of it. The newer research from 2021 by Sakajiri et al. Is that zinc also binds ceruloplasmin, and it binds transferrin, and it actually makes a little bridge, and it forms this amazing structure where there's 3 zincs, and they link the ceruloplasmin to the transferrin, and 2 ceruloplasmins come along, and they bind the transferrin in the middle, 3 zincs on each side, and 2 ceruloplasmins. And they pass 2 irons along to the transferrin. Now, this amazing structure, it helps the transfer. It's not necessary like the copper is, so that the oxidation of iron won't happen without the copper. But the transfer will happen more efficiently if there's zinc present. So that's a neat little thing about how zinc helps the process, and in some contexts, zinc can help out copper. But we also know that if there's too much zinc, like on the order of almost every supplement you can find that has zinc in it, even if it also has copper, that then it's going to block the copper because it promotes the metallothioneins, and they take up the zinc and copper in the gut, and then it gets sloughed off and it leaves the body before it can get absorbed. So we don't want to overdo that process with high zinc supplements at any of the ratios that are in these common supplements. So I think zinc does play a role, but the whole food amounts are good. So I'm not going to give a number there.
I was waiting for it. John, I've been waiting for that ratio. Well, let me put it differently. So we don't sort of hold you to this. If a cow is healthy, eating its ancestral diet, and the soil is good, what would the ratio of copper to zinc be in beef liver?
Yeah, it's a good question. We don't have very much good information about that because what we have is the nutrient databases. And honestly, I don't remember what it says about how much zinc is in the liver. I know that the copper varies wildly between samples, even in the same nutrient database. So
Okay.
we don't really know, I don't think.
So, at least with the blood testing that is in the full Monty, it sounds like you do a similar thing, if not the whole panel. It looks like the plasma zinc and the serum copper are at parity. That is what is looked at or looked for. That doesn't necessarily mean what's happening in the tissue, but at least within the blood, it's a 1-to-1.
Yeah, they should both be around 100.
Okay. Okay.
So 1-to-1 in the blood, that's a different ratio than what people are taking as supplements. So that's
Right.
interesting, right?
Yeah. And right. And so, yeah, I hear you with and let's segue here because we could get even more granular about this whole mineral relationships and whatnot. I'm afraid we're going to lose people if we haven't lost them already. But a key thing here that got me thinking about about all this is the soil. And so obviously if you're tracing, you're trying to get nutrition in a world that is high calorie and low nutrition. It seems like we have a lot of malnutrition people that are eating a lot of food, which is a kind of modern phenomenon that didn't exist before industrial farming. But that seems to be more and more the situation because of soil depletion. I didn't really know what that meant until recently. And that got me studying a lot of regenerative farming, which is basically soil centric farming, and farmers that are trying to build soil rather than to maximize crop yields. And so what does that mean, right? What does that mean to build soil? And what is involved in soil that gets the minerals from the soil into the plants so that we can eat those plants, or the animals can eat those plants, so that we can get those minerals and the vitamins that are all made in the correct amounts. And I just assumed that it was, well, the minerals aren't there, so the plants aren't getting them. But what's actually at play is the microbiology of the soil is what's regulating that entire transfer of minerals to plants and upward eventually to us. And that's why regenerative farming is so crucial for health, from a health standpoint. And I don't think enough people are talking about that. There's a bunch of documentaries that are out, and it's sort of like the premise is regenerative farming because climate change.
Mm.
And my view is, well, okay, yeah, that's true, but how about regenerative farming because health? Like we're growing food to eat. That is the primary reason that we're doing it. We're not doing this new farming way because of climate change predominantly. We're doing it because we need to be healthier. And so um, I wonder if you have explored, you mentioned talking about soil a little bit. What are your thoughts on soil?
I think what you're talking about is incredibly important, the regenerative farming. So the the health of the food chain goes all the way up from the soil. So healthy soil, healthy plants, healthy animals, we're animals, healthy people. But it doesn't stop there either, because we have these microbiomes inside us, in our gut, but also all over us. And the nutrients keep going in the food chain inside us. So we're not just beings, there's biomes inside us, and we're supporting those. We have this illusion that we're one because we have this consciousness. But actually, there are all these organisms inside us. There are even like ecosystems, biomes, different terrain. Like if you go on a hike through the desert around here, as you climb or as you walk up a canyon or you walk a little bit, you'll notice little changes in the terrain. And the same will happen inside your body. So that food chain and the information that comes from the soil, the nutrients that come from the soil, it keeps going on that hike inside you after you eat the food. So we can add, after healthy soil, healthy plants, healthy animals, healthy people, healthy gut, healthy mitochondria. The mitochondria are like little ancient bacteria that are living inside our cells, making our energy. And it's all connected. And then, of course, the microbes come back out and they become manure or compost, and they go back to the soil and they help that process. So it's really all connected. And at every stage, the microbes are helping us or hurting us. The closer it is to the natural state, the better. We're made to work together. And the healthier the soil is, the healthier we are inside. It goes all the way up the chain. I heard Martha Carlin say something like the soil biome and the gut biome are connected. So it's just that one is an extension of the other.
Can you talk a bit more in detail about that? It's definitely an area of interest. I've heard that sentiment before. Um, the person who put it to me was the founder of the GAP system, McBride, Dr. McBride, who uh, was telling me when I interviewed her earlier this year that most of the new knowledge that we have about how the microbiome in our bodies is interfacing with the rest of our body is coming from soil scientists. That's kind of where the leaps are being made right now. Um, but how that is occurring, or some of the major mechanisms of action, are there, I'm ignorant to. So, what can you tell us about the mineral relationships between our microbiome and how we're utilizing that, I guess, ultimately at the mitochondria?
Well, let's start in the soil. So this has been known for a long time that the soil affects the nutrient uptake. There's this great video, I think from the 1950s or so, by the soil scientist, Dr. William Albrecht. It's called The Other Side of the Fence. And you may be able to find it on YouTube or otherwise on the Internet Archive. And it was re-released by Acres USA. It shows these cows that are grazing, and what they want to do is they go right over the fence at the edge of the field, and they try to eat the grass on the other side of the fence. And the reason is because the farmer on the other side of the fence has better soil and the grass is growing better, and they can tell the difference. So they have their original intuitive sense and they can tell the difference. And then he goes on to show, like he shows 2 stalks of celery that look exactly the same, but one is full of nutrition and the other has nothing more in it than a glass of water. There are, it's an excellent interview with Dr. Campbell McBride. I was watching it. There are, as she's mentioning, these networks of fungi that are the highways around the soil. And they help the plants uptake nutrients, including minerals. And the microbes also are involved in the weathering of the rock underneath to break down the rock and make more minerals. And the microbes are involved with breaking down any compost or old organic matter that should get added to the soil in natural farming methods, but the industrial agriculture doesn't. So we need to break down more of the rock to make more topsoil. And we need to break down the organic matter. And we need the help of the microbes to take up the nutrients into the plants. Industrial agriculture does the opposite. They use chemicals that block the uptake of nutrients or chelate the nutrients so they're not bioavailable. So the amount of nutrients that are in the plants is greatly affected by what's in the soil and also by this microbial life. And then that passes up the food chain because what the animals get, including us, depends on what's in the plants. And if we eat other animals the same, it depends on what was in the plants that those animals were eating. And then, of course, we're eating for all of us inside, not just the one that's thinking, but all those other organisms that are inside us. And that microbiome is going to respond to what nutrients it gets. So if we have a synthetic artificial soil, then the plants we're getting really are different plants. And the animals are different animals. And our microbiome is going to be adapted to a different food source because we're not eating real food if it's not coming from real animals that came from real plants that came from real soil. There's this nutrient called ergothioneine, an amino acid with a thiol group like glutathione. And it's kind of neat because it's been demonstrated. So the ergothioneine acts as an antioxidant, a sort of an assistant to glutathione. and the body has a system to distribute it to the cells where it's needed the most. Glutathione also helps deliver copper. That's a very important aspect of glutathione.
Oh, interesting.
And
okay.
maybe the ergothioneine might help with that too. But anyway, the ergothioneine, it goes up the food chain, and this has been shown in the scientific studies that when the soil is tilled, that breaks up these fungal networks. It reduces the fungal life in the soil, and then the plants can't get the ergothioneine that the fungus have made. It's lower in the plants. So that's the research of Dr. Robert Bielman and his colleagues. And he's very excited about the regenerative agriculture. And he says, look, we found this ergothioneine. It's a definitive link showing that the health of the soil is affecting the health of the people.
Yeah, gosh, John, you really are connecting some, you're stating things in terms that really kind of land for me around tilling, because I have recently, yesterday, it's probably going to roll out. I think this interview will roll out. It should be out before this airs, but uh, the director of a new documentary called Roots So Deep, who's actually based in Phoenix. He teaches at ASU, and he's got a great regenerative farming documentary that he has just released. You can watch snippets of it, like 10, 15, 20-minute snippets of it on YouTube. And he's visiting all these regenerative farms and farmers that have converted over from conventional chemical ag to this new methodology, which is basically just like nature-based farming. It's like cooperative. It's like a nature co-op. You're just kind of like doing things that let nature do most of the work, and you and so a big piece of this is no tilling and cover cropping, and so that but what I haven't heard that you just stated was this sort of fungal net that provides this essential structure through all of the soil, and how crucial that is. Like, I'm aware of these fungi that are breaking down rocks, but that was another thing that you put that was like, yeah, we need more of that. Like, that's how you build the topsoil. You build it by breaking down these larger structures of minerals that are not available to the plants. And so that is another way to rebuild the topsoil.
Yes, yeah. And that ergothioneine, it's made by the fungus. So we don't make it, plants don't make it, animals don't make it, and fungi make it. Certain bacteria make it, such as spirulina.
Huh.
But when it goes in the food chain, it starts with the fungus. So there's another role, is that the fungi may make certain compounds that are valuable to us. So another example was vitamin B12 is made by bacteria, and then that passes up the food chain, and we can get it from other animals, or we can get it. It has to be originally made by the bacteria.
Well, I feel like we could keep going, but we've been at it for almost an hour and 20 minutes. So let listeners know how they can get in touch with you and learn more about you.
Yeah, let me say one more thing about the soil.
Okay.
What happens inside us, it's just like the pollution that people are talking about so there's a lot about chemicals and climate change, but we're part of nature too, and the chain continues inside us. So when the chemicals or the imbalanced food or the food that's grown in poor soil, when that goes into us, that's pollution too. And if you think of what happens inside us as internal pollution, well, the good news is we can do that ourselves. We can clean things up. We can do the regenerative agriculture. There are many more opportunities to buy food from regenerative agriculture, and it's growing rapidly. But the results are the same for the pollution outside us and the pollution inside us. If you look at health, there are all these hockey stick graphs with all these different health conditions that are growing exponentially, the patterns that we're seeing on hair and blood testing that are different than before. Now most people are slow oxidizers, unlike in George Watson's time. But that's what it looks like when we do unnatural things in any place in the food chain, starting with the soil. I mean, it happens outside of us and it affects the air, but it's happening inside us too. And that's our health. And we can do something about it, and we can rebalance the minerals. And I'm really glad you're emphasizing the regenerative agriculture, because that's a very important part. So people can find me at minbalance.com, MINBALANCE.com. And
Okay.
yeah, I would usually do recommend both the hair tissue mineral analysis, and it has to be from a lab that doesn't wash the hair at the lab, because that will wash out some of the important minerals. So there are two labs, ARL and TEI. TEI tests somewhat more minerals. That's the lab of Dr. Watts, whose paper I was reading from before. So I can arrange the test through TEI, or sometimes people bring me their own hair test, which is fine. The blood test people can obtain through a doctor, or you can order it privately in the United States from Request a Test or from Ulta. And yeah, all the information is there on minbalance.com.
Thank you. Thanks, Jon, for taking your time to speak with us. Good luck with everything.
Yeah, thank you. You too.